Hi there. Thanks for joining me today. My name is Puneet and I'm head of data science and data engineering at Carousell. I'm very excited to share my thoughts on this interesting topic, why you need AI for personalization and how to build explainable AI in-house. Here is the agenda. I will start with sharing some context around Carousel that will later help me with when I use examples from Carousel to make my case. Then I will talk about how AI can really help power high performing, personalized recommendation feeds. From there, we will get into the primary topic for this talk, explainable AI. I will first make a case for why we need AI predictions to be explainable, and then share important strategies that will be helpful to build explainable AI models in house. Let's get started. Carousel is one of the largest and fastest growing classifieds marketplace in the world. Carousel is available in 8 Southeast Asia markets now. Millions of users use Carousel on a daily basis and have created hundreds of millions of listings on the platform. 8 years back, Carousel co founders started this journey with a mission to inspire everyone in the world to start buying and selling from each other, making second hand the first choice. It has been an amazing journey, and the recent investments by prestigious groups like Naspers, Telenor, and Naver has brought the company valuation very close to the magical $1 billion mark. Data science team at Carousel is responsible for leveraging the power of machine learning and AI to serve company's mission. And there are a wide variety of interesting, challenging, and impactful problems the data science team has been working on. For example, helping sellers at the time of listing creation with title, category, and price suggestions, and helping buyers find relevant and quality items via search and recommendation algorithms. As we will see, the need for explainable AI is felt across the board. With that context around Carousel, let's start with the topic for this talk. But before we talk about explainable AI, let's start with why AI? Why do we even need AI for personalization in the first place? Personalization at a high level has three important components. First, there is content that you want to recommend. For example, listings on Carousel or videos on YouTube. Then, of course, the consumers or users of this content. And finally, the personalization algorithms that match the content to the users. Let's see how AI can prove to be a game changer for each one of these. Starting with content. Content is like an iceberg. Without AI, we have a very shallow understanding, only the surface level. AI allows us to develop a deeper understanding of this content. It goes beyond syntactic and gains semantic understanding. It enables us to discover content associations and gives us the ability to predict. Let's look at this further using an example. This is an example listing from Carousel. Here, someone is selling a second-hand iPhone X. Let's see what useful questions can AI help answer that are hard or near impossible to answer otherwise. For example, questions about image quality. How appealing or repulsive is this image? How can AI help make it more attractive? Then comes to price. What would be a fair price for the second-hand smartphone? Is this one a good value for money? Once we know that a user is interested in buying an iPhone, what next? Can we show some similar iPhone listings or even other smartphones as alternate options? We can even recommend AirPods as they are related. All these are important but tough questions. It requires smart AI solutions to make dependable predictions. Now, let's move on to our second dimension, the users. Just like content, by default, we have a very narrow understanding of our users, standard demographic information, and activity history. But there is so much more to our users than just that. AI helps us develop a more holistic 360-degree view of our users. Let's again look at an example. This is a hypothetical user on Carousell. Any resemblance to me is purely coincidental. Let's say there are various listings that this user explored or even bought during last few weeks. I will wait a sec so that you can get a feel for it. Now, a narrow view of this user would be 40-year male who often browses and buys toys and books. Now, that's not bad, but it's still very limited. If you look closely, you can clearly see more interesting patterns. For example, what age group do the books and toys belong to? Genre and author affinity for the books, brand and category inclination for the toys. This kind of deeper user understanding can help answer many useful questions. For example, what would this user like to buy next? What matters to this user? New versus used, meetup versus delivery. It's not hard to imagine how such comprehensive user understanding will allow us to better serve our users. Now we have reached the third pillar of personalization, the matchmaking. This life partner compatibility table here is pretty representative of how we typically go about matching content to users. This user is a dragon, and all dragons love rats. Let's show all rats to this user. He would love it. Sounds familiar, right? I believe this approach is like painting the wall, using a very broad brush. Every single brick is painted exactly the same. And this is what a deep learning based relationship matchmaking algorithm might look like. According to the supporting article, this ML model was able to spot mutual interests, find compatibility based on emotions and personality patterns, and is even robust against deceptive presentations. This definitely appears more trustworthy than depending only on your date of birth, isn't it? Now, don't get me wrong. I'm not recommending that you let AI decide your life partner. The point I'm trying to make is that AI will take rich content understanding and user understanding signals as input and provide us with the ability to make very fine matching decisions. In contrast to painting the wall, AI provides the tools to create fine art. But there is no free lunch. Often, the improved accuracy and prediction capability of AI models comes at a cost of transparency and explainability of their predictions. This is where simple rule based recommendation models score over more complex machine learned models and the topic of our discussion. Let's say if Carousel algorithm decides to recommend these listings to this user based on his activity history, he might be interested in knowing why. If you look at Netflix home screen, it has a mix of recommendation sections. Some recommendation sections are self-explanatory. For example, because you watched blah, while others are unexplained. For example, top picks for you. You might be wondering, why is it even important to explain the content recommendations for Carousel or for Netflix? Fair enough. Let me share more on that now. But before that, I would like you to play a small game with me. Please close your eyes and think of a shoe. Okay, now I'm quite sure different audiences would have pictured a very different shoe. Something like this, or this, or this, isn't it? And I wouldn't mind putting my money that no one would have thought of this. Why? because all of us have our own bias. And just like humans, even AI has bias. AI models learn from the historical data that is fed to them. Hence, any bias in the data is then reflected or even amplified in the future predictions that the model makes. An example of this came to light in 2015. Amazon's engineers discovered that their resume screening algorithm had learned that historically the majority of the technical roles were filled by males and thus penalized a resume if it included the word woman. Similar concern was discovered for Google's job ads algorithm that showed high paying job ads to men but not to women. Here is another example of bias in Google search algorithm. When searching for CEO, the top results are all white men. And when you search for female construction workers, the top results are women models in skimpy costumes. Possibly even more concerning are scenarios where AI is applied for healthcare. One example is the British health app Babylon. To women, it suggested that sudden pain in the left arm or nausea may be due to depression and advised them to see a doctor in a few days. In contrast, males showing the same symptoms were advised to immediately visit an emergency department based on the diagnosis of a possible heart attack. Think about it. Yet another high profile issue was investigated by ProPublica, an algorithm used by the US criminal justice system that predicts the risk of defendants to reoffend once they have served their sentences. Based on the algorithm's results, judges determine which defendants are eligible for probation or treatment programs. In ProPublica's study, the authors demonstrate that the algorithm is biased with respect to ethnicity. Afro Americans are almost twice as likely as whites to be labeled a high risk but not actually reoffend. It makes the opposite mistake among whites. They are much more likely than blacks to be labeled lower risk but go on to commit other crimes. We are not done yet. In November 2019, a Danish Apple Card user uncovered that Apple's AI algorithm granted him 20 times the credit limit that his wife received. This disparity came as a major surprise as the couple shared assets and she actually had a higher credit score than he did. Apple and Goldman Sachs, who partnered on this financial product, repeatedly assured that this wasn't a case of discrimination. But what started with a viral tweet brought more and more cases of bias to the surface and ultimately led to an investigation by the New York State Department of Financial Services. To conclude, any undesirable bias in AI models can have significant negative impact on the society. It is pretty obvious for domains like healthcare and medical diagnosis, legal and law enforcement matters, and financial opportunities like loan eligibility or equal employment opportunities. Another important but less obvious domain is social perception. What we today read, hear, watch is heavily influenced by what AI algorithms recommend to us. It influences our perception about people, political parties, and important societal issues. Any bias in these recommendations can literally shape the way our society evolves. So, how do we avoid bias in AI systems? As is obvious, data is the most important aspect. Making sure that training data is well representative of the diverse use cases would be the first step. Also, having a diverse set of team members involved in the model training and evaluation often helps catch model bias issues early. Not all scenarios need the same level of scrutiny when it comes to AI bias. Identifying which scenarios are more critical would be useful. Then, for such important scenarios, model developers should put explicit focus on avoiding bias and identifying evaluation ways to test the model against all possible biases. Though prevention is better than cure, it is almost impossible to have a bias free AI models. Trust me. Often we don't know what we don't know, and that's the problem here. Hence, the need for explainable AI. Explainable AI refers to methods and techniques that help us interpret and comprehend the predictions of an AI system. And this has many advantages. It helps debug and fix the model limitations. Now, explainable AI is often a prerequisite for certain sectors like healthcare and banking. A user's perception of bias in algorithms can do irreparable damage to a company's reputation, and it can literally make a life or death difference in some extreme scenarios. And all these factors contribute significantly in building trust with stakeholders. I strongly believe that lack of explainability might prove to be a deal breaker for widespread AI adoption. Now that we are convinced that explainable AI is important, let's discuss how to go about achieving it. We can design for explainability in our AI systems at three different stages. Pre-modeling stage, that is, before the model has been trained. Modeling stage, when we are training the model. And post-modeling stage, that is, adding a layer of explainability on top of an existing model. As part of pre-modeling explainability, the first aspect is EDA, or exploratory data analysis. Model developer should explicitly look for data representation across segments. For example, when making improvements to our search algorithms at Carousell, we explicitly measure how will this impact our popular queries versus tail queries. And for recommendations, we look at how would this impact our new users versus repeat users. Then comes feature engineering. Now, model predictions are explained in terms of features that contribute to the predictions. If the features are not comprehensible, the prediction explanation would be useless. In this case, we are talking about a chair classification. In this chair classification task, the camera angle, product width, and leg style are much more understandable features as compared to, say, a black patch of pixels in the top right corner. That's very hard to interpret, right? Finally, you can also build some simple nearest neighbor search based models to get a feel for examples with poor representation. This can provide actionable insights to create more balanced data. Coming to model training aspect, the first and most obvious one is pick an inherently more explainable model architecture. For example, a decision tree like this one can literally lay out its decision making process, right? Whereas a deep neural net model is inherently harder to interpret. Often the concern in choosing a more explainable model like decision tree over a more opaque model like deep neural networks is the drop in model performance. Neural networks are often give higher accuracy, higher performance as compared to the simpler models, which are more explainable. And this is the most important factor, the elephant in the room. The good news is that there have been significant advancements in the field of hybrid model architectures for neural net based models. These architectures provide better explainability without compromising performance. I have listed a few of those options here, like SCNN and CEN, etc. Now, explaining these will get too technical and definitely not in the scope of this talk, but you can read more about them later. The key takeaway here would be that there has been significant advancement in the field of explainable neural net model architectures that deliver good trade-off between model performance and explainability. So this is worth exploring further. Finally, we come to post-model explainability. Now, this is where majority of the work has happened, that assuming a model is already available, how do we now make sense of the predictions this model is making? And there has been a lot of success in this domain. Libraries like Sharp and Lime help get better understanding of the reasoning behind a model's prediction. These libraries explain a model's prediction in terms of the feature significance in making that prediction. They have seen a pretty significant widespread adoption. PDP and ICE also provide very insightful plots depicting the impact of model predictions based on changes in the feature value. In this example, you can see partial dependence of house value prediction on features like income, occupancy, and house age. Going back to our original example of product recommendations for Carousell, instead of a black box approach of powering these recommendations, we have built a more explainable approach. For example, we first map these user actions into human understandable content interests, the user's active buying intents. Then based on our content understanding, we decide what to recommend and why. For example, recommend an HP ink cartridge because user bought this last month and the repeat purchase frequency is almost a month. Or recommend a Beyblade Stadium because it has high post-purchase association with Beyblades. This allows us to be more deliberate about how we construct our recommendations and to make appropriate adjustments based on the user feedback data. To sum up, every lasting relationship is built on trust. Chris Butler said that trust is earned when actions meet words. That is so true for humans, isn't it? And I think in the case of AI, it would be the reverse. Trust in AI is earned when words meet actions. That's why we need explainable AI to give words to AI actions. Thank you.